In this video, we are going to be doing lesson 10.3, relating similar triangles and slope. Okay, our objective is I will use slope triangles to compare the slope between 2 points in the coordinate plane, and also compare ratios of side lengths of triangles to the slope of a line. Okay, and then our essential question is, how are similar triangles and slope related? Okay, well, remember that similar triangles means that they have the same shape but they're different sizes. They're the same shape but different size. And slope, remember, is like the rise over the run. Okay. All right, let's look at example number 1. It says, draw the triangle that is the image of the given triangle after a dilation with center 0, -2, and a scale factor of 2. Look at the ratio of the rise to the run of each triangle, and how do the ratios compare? Explain. All right, so the first thing you want to look at is the given triangle. All right, here's our given triangle. And they want us to draw an image triangle with center 0, 0 after, with a dilation with center 0, 0 after a scale factor of 2. Okay, remember the scale factor is very important. If the scale factor is 2, that means that your new figure, the image figure, is going to be twice the size or 2 times bigger than your original figure. All right, so let's see. We're using slope triangles to compare the slope between 2 points here. So here's our line. Okay, it's a straight line, so the slope between any 2 points is going to be the same. The slope between these 2 points will be the same between any other 2 points on the line, because it's a straight line. So the first thing we have to figure out is, what is the slope of our original triangle? So let's write down here that the original triangle, okay, our original triangle has a slope. Okay, remember, slope is the rise over the run. So the slope between these 2 points, if you're given a slope triangle, the rise here is 1, 2, 3. So your rise is 3. Right, that's your rise. And the run of this triangle between these 2 points, the run is 1, 2. So the run is 2. All right, so our original triangle, the rise is 3 and the run is 2, so we have 3 over 2 as the slope of the original triangle. Okay, which means the slope between these 2 points is 3 over 2, because that's the rise over the run. All right, and we need to figure out the image after a dilation with center 0, -2 and a scale factor of 2. Here is the center, because this is at 0, -2. Right, that point, here's your y and x-axis, so here's 0, -2. And the way that we figure out the new figure after a scale factor of a 2 is you take your original rise over run, which is 3 over 2, and you have to multiply the rise and the run by your scale factor. So it's going to be 3 times 2 and then 2 times 2, which gives you your new rise over run for your image figure. So it would be 6 over 4. right? And that makes sense because remember, if the scale factor is 2, that means that the new image figure is going to be twice the size of the original figure. Okay, the scale factor is bigger than 1, so it means it's going to be an enlargement. It's going to be twice the size. And 6/4 is twice the size of 3/2. So now we have to figure out, well, how are we going to draw that triangle here on our coordinate plane? Well, this is very important, the fact that they tell us that the dilation has center 0, -2. So you start here, okay, at the center, 0, -2. And again, since our scale factor is 2, we have to do twice the size of what it is. So if this side of the triangle is 2, we know that the new run needs to be 4. So it's 1, 2, 3, 4. So our figure goes out to here. Okay. And then our new rise is 6, so we have to go up 6. 1, 2, 3, 4, 5, 6. So here's our new triangle here. It's twice the size, right? Because the scale factor is 2. Okay. So here, again, here's our original triangle, and here's our new image triangle after a scale factor of 2. So here, right, this line is 4 units long. That's the new run. Equals 4. And the new rise here, the new rise is 6. Okay, so let's write that down. Okay, that the image triangle has a rise over run, which is 6/4. Okay, that's the image triangle. Well, actually, if you look here though, but 6/4, the rise over run, if you reduce that, if you divide by 2, right? Here, if you reduce this fraction, 6/4, if you divide the top and the bottom by 2, it's 3/2, which is the same rise over run as our original triangle. Okay? It's just that the rise over run is reduced, which is proving that, see these two triangles? These are similar triangles, right? Because they have the same shape, but they're not the same size. 3/2, and then if you double it, because the scale factor is 2, it's 6/4. But when you reduce 6/4, it's 3/2, right? Meaning that the distance between these 2 points, 1, 2, and the distance between these 2 points are the same. I'm sorry, the slope between these 2 points and these 2 points, not the distance, guys, the slope. The slope between any 2 points on this line is going to be the same. We just proved that. Okay, because the slope between these 2 points, this and this, is 6/4. 6/4, but it reduces to 3/2. All right, so how can we, it says, the question says, look at the ratio of the rise to the run of each triangle. How do the ratios compare? Well, the ratios of the rise to the run right, we're comparing them. The ratios of the rise to the run of the two triangles are the same, right? Because the rise over the run of the original triangle, slope triangle, is 3/2, and the rise over the run of the image figure is 6/4, but 6/4 reduces to 3/2. So essentially the rise over the run for both of the slope triangles is the same. Okay, that's the important thing, which makes sense because the slope between any 2 points on a straight line is the same. Okay, now try the got it, and then watch the video to make sure you have it correct.